The situation says that a researcher wants to determine if the time consumed in using social media differs in hours of sleep per night of the adolescents. They are grouped into low, average, and high levels according to their social media use. Each group have 50 participants or observations. Each participant in a group has a certain hours of his or her sleep, with a minimum of 1 hour and a maximum of 9 hours. We have here 3 groups, and each of them has 50 participants. So we have a total of 150 participants or observations. Before we proceed to the calculation, let us first make our objective. Is there a significant difference in the hours of sleep per night between each group? Our hypothesis in the null form will be there is no significant difference in the hours of sleep per night between each group. Our significance level should be set to 0.05. The confidence interval is 95%. Then we have the results. We have the results for normality test based on the p-value for group 1, group 2, and group 3. Result number 1 includes the means from group 1, 2, and 3. And result number 2 for the probability value. We proceed to normality testing using the Kolmogorov-Smirnov test. Let's copy our dataset for group 1 to test if they are normally distributed or not. And then paste it in the text box, then calculate. The result of the p-value for group 1 is 0.08069. It is greater than our significance level of 0.05, which means that our data is normally distributed. The mean for this dataset is already indicated here. So we have the mean of 7.56 for group 1. Okay, next is for group 2. Same procedure. Let's copy and paste the dataset, then calculate. So for group 2, we have the probability value of 0.07435, which is greater than the significance level of 0.05. Therefore, this dataset is normally distributed, and its mean is 5.56. Lastly is for group 3. So the calculated probability value is 0.05068. It is normally distributed because the probability value is greater than 0.05 and its mean is 2.4. Before we proceed to the calculation for ANOVA for independent samples, let us first interpret our result number 1. So, which of these groups has the highest mean? Group 1 has the highest mean, which means that this group has the longest hours of sleep among other groups. On the other hand, Group 3 has the lowest mean. This group has the shortest hours of sleep among the 3 groups.
Let us now go to the calculation of probability value using the ANOVA for independent samples. We can see here that we can put up to 5 treatments, but since we only have 3 groups, we will use treatment 1 for group 1, treatment 2 for group 2, and treatment 3 for group 3. So let us copy our data sets and paste it in their designated text box. And make sure the significance level is set to 0.05 and then press calculate. So the calculated probability value is 0.0001, and if the probability value is greater than the significance level of 0.05, then we will accept the null hypothesis. Otherwise, the null hypothesis will be rejected. We got a probability value of 0.0001, which is less than 0.05. In this case, we will reject the null hypothesis. And so, our data analysis is the given dataset had been treated with one-way ANOVA for independent samples since each group were consist of different participants or respondents. Each group had been tested with Kolmogorov-Smirnov test of normality with a result of computed p-values equivalent to 0.08069, 0.07435, and 0.050684 for Group 1, Group 2, and Group 3, respectively. These values suggest that the dataset in each group were normally distributed since their computed p-value is greater than the significance level of 0.05. Descriptive statistics result shows that the mean of the hours of sleep of group 1 is 7.56. The group 2 has the mean of 5.56, whereas the group 3 generated 2.4 mean of their hours of sleep. The result of the means of each group shows that Group 1 has the highest mean, which suggests that this group has the longest hours of sleep among other groups. On the other hand, Group 3 has the lowest means. Thus, this group has the shortest hours of sleep among the 3 groups. On the other hand, treating the 3 datasets with one-way ANOVA for independent samples, it yields a p-value of 0.0001, which is less than the significance level of 0.05. This implies the rejection of the null hypothesis. Therefore, the hours of sleep per night between each group have a significant difference. In the analysis for determining the difference between the levels of social media use and hours of sleep per night of the adolescents, results showed that adolescents with high level of use social media use tend to have low number of hours of sleeps. Poor sleep quality had a statistically significant difference with a high level of social media use. On the other hand, results showed that the lower the level of social media use, the greater hours of sleep was determined. The study of Haising M. et al. 2015, Arona Palacios A. 2017, King D. L. et al. 2013, Noyotinen T. et al. 2013, and Reynolds C. M. et al. 2015 have demonstrated the use of electronic devices causes sleep damage by keeping late bedtimes, limiting the sleep hours, and sleep quality disturbance. In another study, Wong H.Y. et al. 2020 suggests that both severities of internet gaming disorder and social media addiction are associated with more psychological distress and poorer sleep quality. Choi et al. 2009 reported that internet use is strongly associated with excessive daytime sleepiness in adolescents. Furthermore, a study by Afandi et al. 2013 reported that non-users of social networking sites or SNS had better sleep quality than users. Although SNS were not mentioned in a study of Swedish adolescents by Söderqvist F. et al. 2008, it was reported that regular users of mobile phones had health symptoms such as tiredness, stress, headache, anxiety, concentration difficulties, and sleep disturbances more often than less frequent mobile phone users. Previous cross sectional studies have consistently shown that the frequency of social media use is associated with several sleep problems among adolescents. According to Peya R.D. et al. 2012 and Wood H. C. and Scott H. 2016, adolescents who frequently use social media during the day report less total sleep time and poorer sleep quality. These related studies support the implication of this study based on the analyzed data. This is strong evidence linking hours of sleep with social media use.